Hello all, and welcome to whatever week this is, week 5, I think, of online algebra. We're going to be jumping into chapter 11 here for just a couple of sections before moving on to some stuff in chapter 12. So chapter 11 deals with rational expressions. We're going to start with simplifying them. Now, rational expressions are going to look a lot like fractions, so we're going to want to remember our rules for simplifying fractions. How do we simplify 2/6 or 6/8? Well, remember, this might be a little simple. You might know how to do this in your head. But remember, we split these up into their most basic forms. So 2 is 2 times 1. 6 is 3 times 2 times 1, right? So we split these up. You can make those factor trees if that helps you. 6 is 2 and 3, or 2 and 3 and 1. And then we look for things that are the same on the top and the bottom to cancel out. So this ends up becoming 1/3. If we do that with something that's a little bit harder, right? We said 6 is 2 times 3. 8 is going to be 2 times 4, or 2 times 2 times 2. We still look for what we can cancel out on the top and the bottom when we're figuring this out. So this one's equal to 3/4. All right, so we're covering rational expressions. What is a rational expression? A rational expression, let's underline that, is just any value or any sort of function where we have something that looks like a polynomial divided by another polynomial. So some examples of what would be rational expressions would be something like 2x plus 3, that's a polynomial, divided by x squared plus 5x plus 4. Or it could be something like x over x squared. Those are both polynomials. Or you could even have just a number, right? A number is still a polynomial over x plus 3. Any of those would be examples of rational expressions. They're a polynomial divided by another polynomial. Now, the first thing we have to realize before we get to simplifying with these is that we can run into some issues. So we need to be able to do something we call finding excluded values. And what an excluded value is a value that makes the denominator 0. So now that we're dealing with having polynomials, or x's on the bottom, we could be dealing with getting things that are having us to divide by 0, or causing us to divide by 0. Remember, dividing by 0 is a big no-no. It's one of the key rules of math. So we have to figure out ways to make it so that we know not to divide by 0, or we have to show that we're not going to divide by 0. So if we have something like 2 over x plus 1, what we have to do is we have to figure out how to not make the denominator 0. How do we do that? Well, we take the denominator and we say we want our denominator to not equal 0. And then we just solve for x. So to make our denominator not equal to 0, x cannot be -1. And let's make sure this makes sense. Is this an excluded value? Is this something that would make our denominator 0? Well, if we substitute it back in, we'd get 2 over -1 plus 1, or 2 over 0. That's exactly what we want to avoid. So this is an excluded value. We are looking for those values that we can't use for x because they make us try to divide by 0. All right, let's do a slightly more difficult version of this same sort of thing where we're trying to find the excluded values. If we have x minus 2 over x squared plus x minus 2. Okay. We're trying to figure out what makes the denominator 0, so we're going to take the denominator and set it equal to 0 or not equal to 0, whichever way makes you understand this or is easier to understand. All right, Now I'm going to be doing a lot of factoring throughout these, so make sure you're comfortable with it. I'm going to be skipping most of the ACB charts and just going to the factors. If you're confused, see me in office hours or find one of those videos online to help you with factoring. Now the factors for this are going to be x plus 2 and x minus 1. And so right, we're setting this equal to 0 or not equal to 0 because we don't want the denominator to be 0. But because this is equal to 0, we can split this up. Remember, we split these up to figure out what x is equal to. So we get that it's -2 or 1. And because these are the excluded values, or the values we can't use, x can't be equal to -2, and x can't be equal to 1. So that's how you find excluded values. You look at your denominator, then you go ahead and solve for 0 or solve for x, and that's the value it can't be. All right, now let's move on to simplifying these rational expressions. How do we simplify a rational expression? So first we're going to have to use that new information we had. We want to find our excluded values. But then we're going to treat this like we were treating fractions at the start. Then you factor, split it up into the most basic parts, then you cancel. So let's run through an example of this. If we were looking at x minus 1 over 5x minus 5, the first thing we have to do is find our excluded value. So we say, what can't x be? Well, it can't be 0, so we're going to solve for this. We get x can't be 1. So this is what we have to start with. Now we're going to factor. Now we're going to take out like terms. Nothing on the top can be taken out, but in the bottom, both of these are divisible by 5. So we can divide by 5. And what are we left with? X minus 1. Look at that. We have something on the top and bottom that can cancel. So those are going to cancel. What are we left with? We're left with, there's nothing left on the top, so it's just a 1, and we have the 5 on the bottom. But the key part is we also have to include that excluded value. We know that x cannot equal 1. Let's make sure that we're including this every time we're going to be doing one of these simplifications. All right, let's do a harder one. Now let's do 3x minus 6 over x squared plus x minus 6. We're going to start with the bottom, find those excluded values. So we set that equal to 0 and solve. Once again, I'm not going to do this factoring. This comes out to be x plus 3 and x minus 2. And that's going to equal 0. So we figure out what this can't be. And it can't be whatever we solved for, and it can't be whatever we solved for. So these two values x cannot be. Great, now let's factor. So factor a 3 out of both of these. They both have a 3 that's divisible. What are we left with? X minus 2. And one of the nice things about finding these excluded values is we already factored the bottom, right? This is the factors. So we can just use that up here. We already found those, so we'll just put them in here. Remember, you can always double check, make sure those are right by foiling this out. Right, and step 3, cancel. So is there anything the same on the top and the bottom? We have an x minus 2 and an x minus 2. Meaning that this is equal to 3 over x plus 3, and then we have to include our excluded terms. So this is 3 over x minus 3, but we know x can't equal negative 3, and we know x can't equal 2. Always got to include those. Remember, we go find our excluded values, factor, then include those, and finish solving. All right, one more here. Now let's say you're looking at this now. You have 3 minus x over x squared minus 4x plus 3. Now the first thing we'll notice is this top here is in a different form. We usually like having x in front. We'll deal with that in just a second. But let's start by doing what we always do. Gonna take this and set it equal to 0. We're gonna find those excluded values. X squared minus 4x plus 3 is equal to 0. Okay. Now we're going to solve for this by factoring. You'll get that it's x minus 3 and x minus 1 is equal to 0, meaning that we split this up. And we solve. So we know x can't be 3 and x can't be 1. Now we already did the hard work of factoring that bottom, so we're just going to use that up here. Over x minus 1. And we're left with 3 minus x on the top. Now you'll notice these two terms look very similar, but they're not the same. You might think, wow, that's frustrating. Can we do anything to cancel them out? And the answer is you actually can. When you factor out a negative, it switches the places of these two. So factoring out a negative switches places. So if we factor a negative out, the x and the 3 switch places. And would you look at that? Now we have a term that's similar on the top and the bottom, so we can cancel those out. So remember this nifty little trick here. If you have two things that look almost the same, you can factor out a negative to flip the places. All right, so this one comes out to be negative 1 over x minus 1, but we need to include those excluded terms. So we know x can't equal 3, and we know x can't equal 1. That's all we have for new material for this lesson. So I'm going to give you a practice problem or 2 or 3 here. Make sure you're pausing the video to actually do these practice problems and make sure you're understanding. First, I want you to find the excluded values on 2 different problems. So find the excluded values if the equation or the rational expression is 1 over x minus 2, x plus 2. And I also want you to do that for 2 over x squared plus 2x plus 1. And then you're going to simplify. You're going to simplify. We'll do 4 minus x over x squared minus 3x minus 4. So pause the video right now, give each of these a shot, and then come back when you're finished. Make sure you're actually pausing the video to do these. All right, welcome back. Let's get started with these excluded values. Remember, the excluded values come from the denominator. So we're going to set the denominator equal to 0. And then we're going to split these up and figure out what x can't be. So it can't be 2, and it can't be negative 2. What about for this one? For this one, we're going to have to do the factoring ourselves. So again, we set this equal to 0, but now we have to factor. When we do these factors, let's do a quick ACB chart. We're looking for factors of 1 that add up to 2. So this becomes x plus 1 x plus 1 is equal to 0, right? 1 times 1 equals 1, but it adds up to 2. And then this becomes x plus 1 is equal to 0, and x plus 1 is equal to 0. So we know x cannot be negative 1. And then for this one, we are simplifying. So we still have to start by finding the excluded values. So we'll get x squared minus 3x minus 4 is equal to 0. Put that in, we will find that that's actually equal to x minus 4, x plus 1 is equal to 0, meaning that x cannot be positive 4 and x cannot be negative 1. Great, so we have our two excluded values here, and we have our factors. So let's factor that. So we have 4 minus x over x minus 4 times x plus 1. Now this is super close to being able to cancel. What can we do? We factor out a negative to flip these two places. This is the same thing as negative, and we flip the places. And now we can cancel. So this is going to be equal to negative 1 over x plus 1, and then we have to include those excluded values. So we know x can't be 4 and x can't be minus 1. All right, that's all we have for this lesson. Go ahead and do the homework.